I am Siti Nur Arina Azwa binti Syed Salahuddin, Chemical Engineering Department, 17005763.
My name is Ilya Bajatunaja binti Ahmad Faisal, number of ID 18002X71 from Chemical Engineering Department.
My name is Adam Iman bin Ahmad Salahuddin Al-Thani, match ID 17003626 from Mechanical Engineering.
My name is Arya Aswa bin Azri. My ID number is 17000739. I am a computer engineering student.
Hello, I'm Ashwin and my ID number is 16003361 and I'm from Civil Engineering Department.
I will start with the introduction. So our project, which is a smart bin for smart city, created mainly to handle the waste management in Malaysia in a better and efficient way. So the problem that we are currently facing is, firstly, where the cleaners in skyscraper buildings or multiple story residences are facing difficulty in detecting full trash bin, where they need to constantly check up on full trash bag for disposal. Secondly, the habits of uncultured people, where they keep throwing rubbish in full trash bins. And thirdly, is the manual self-sealing of garbage bag, which is very inconvenient since we have to touch the garbage bag to tie it up before disposing it. The objectives for our project are to help cleaners coordinate better in handling multiple bins in skyscraper buildings such as malls and offices. Next, to reduce the needs for collection visits. And thirdly, to promote a clean and conducive environment by introducing these touchless smart bins.
So the first one is I will talk about the feedback survey analysis. So the figure above shows the result of survey for question 3, which is about the opinion on the design concept of smart bin. 100% of respondents, which are 61 people, are totally agreed with the design concept of the project. Next, I will explain about the design thinking of this project. Firstly, we identify the main problem of this project, which is uncontrolled waste management. Next, we have a regular meeting every week to brainstorm the ideas for this project. We also propose few designs and materials based on our research and always ask for advice from our supervisor. We have a design coding made by our smart and talented computer engineering student, Arif Azfar. Next, we have a final product made by a variety types of software such as Arduino IDE, Blink, and AutoCAD. Lastly, we have a presentation and submissions of video and report on week 12. Next, I'll talk about the task contribution of the members in ETP Group 3. So first, I'll talk about Adam. He plans weekly meetings and manages and distributes tasks to the whole group. He also monitors and ensures all tasks are done at a given deadline. He also makes the important decisions. Next, I'll talk about Ilya as the assistant leader. She assists leader and take note of the whole agenda and important tasks in all meetings. She also assists the group in paperwork. Arina, as the secretary, she plans and makes sure all components for the prototype are within the allocated budget. She assembles all electrical components on the device, and she also ensures all components work. Arif Aswa, or Aras, as the technical manager of the group, he solves the problem related to the technicality of the prototype. He ensures the prototype works, and he tests and ensures the safety of the prototype, which is smart bin. And last but not least, Ashwin as a person who is in charge of research and development. He records all findings regarding the project for future reference. He also makes some research on the components used for the prototypes. He also tests and improves the prototype.
For the project planning, as you can see, this is our Gantt chart. Up until week 6, we are more focused on finishing the extended proposal. After that, we are more focused on completing the simulation and animation. For week 12, we are more focused on completing the final report. And as you can see, every week there will be a meeting. Thus, there will be around 11 or 12 student evaluation form. And finally, we will be submitting our peer evaluation form with the final report. Moving on to the methodology part, this is the dimensions of our smart bin. As you can see, it is a 40 by 40 centimeter rectangular trash bin with a height of 51. This dimension is suitable with the standard large size plastic bag in Malaysia. The material of this project is stainless steel. This is chosen because of the high tensile strength, which can withstand the forces that is exerted by the trash inside the plastic bag when full. Other than that, it has a higher melting temperature than the heating temperature that we will be using for the sealing of the plastic bag. Other than that, this is the dimension of our sealer. It consists of gear, motor, and a heater. For the electrical components, these are the main components.
This is a video of circuit and device simulation of SmartBin. The top part of this video is a circuit simulation and the bottom part of this video is a device animation. In this video, I will explain on how the functionality of SmartBin. SmartBin device has three main features, which are: first and foremost, the automatic lid opener. In our device, we use ultrasonic sensor to detect the movement of user towards the smart bin. If the user move close to the device at a certain distance, the sensor will send a signal to the motor which functioning as a lid opener. And if the user move away from the device, it will close the lid of smart bin. The lid will open 90 degrees so that the user can throw the rubbish easily. The second feature is real-time rubbish tracking. Smart bin device detect the level of rubbish bag in the bin using ultrasonic sensor. If the bag is fully filled, the red LED will turn on. Once the red LED turn on, the device will send notification to the user through SMS or through the Blink application that connected with the smart bin. The user gets a notice about the bin is full and ready for sealing mode. The last feature of this device is self-sealing technology. Smart bin device has been coded to automatically goes into sealing mode after the bin is full. The sealing process will take about 50 seconds to 20 seconds for completion. The motor of the sealing will rotate 90 degrees and as the heater touches each other, the plastic bag will be sealed. As can be seen in the video, the sealer does not touch any of the walls or other components of the device. The bottom part of the video shows the sealing mechanism in our smart bin device. However, user also can seal the plastic bag manually by pushing the seal button that on the device and in the Blink apps that connected with the smart bin device. The seal button allow user to seal the plastic bag anytime even though the rubbish is not fully filled. After the plastic bag is sealed, the user can easily leave the top part of the smart bin to remove the sealed plastic bag and change a new plastic bag.
Hello, I'm Ashwin from Group 3. I'm going to present about impact of our bin and economical consideration. As you can see, the impact of our smart bin is to reduce the work of cleaners in multi-level buildings, to promote clean and conducive environment by using touchless bin, and environmentally friendly by reducing the usage of trash bags. And the cost of making our trash smart bin is 190 ringgit and 70 cents. The price of stainless steel can't be confirmed yet because it depends on the thickness of it, but it'll be around 50 to 60 Malaysian ringgit. Thank you very much.
In conclusion, with all the advantages of this project, such as the functionality of the app, the automatic sealing, the ability to locate the trash bins, and etc., it is clear that the objective to help cleaners coordinate better in handling rubbish bins, to reduce the needs for collection visits, and to promote a clean and conducive environment can and will be achieved. For further improvements, it is recommended that future students actually build a physical project to help ease the building of the app. That is all from us from Group 3. Assalamualaikum warahmatullahi taala wabarakatuh.